Hello, today I'll be explaining questions 5 and 6 of round 138 of the grade 8 and under Prairie Math League problems. So I'm going to share my screen and then get started. Okay, first question, what is the area of quadrilateral ABCD? Okay, so this is a relatively simple question because you could probably just like draw a line here, and ideally this line would be straight, but because my hand is kind of wobbly, it's not. But otherwise, you notice that these are both right angled triangles, so you could probably find the height is always here, and then the base is here and here. You can multiply the base times the height and then divide it by 2, and then you'll find the answer. So here you can find that the hypotenuse is just 7 squared plus 4 squared square root, right? So it's just square root of 16 plus 49, right? That's 4 squared plus 7, which is equal to square root of 65. Okay, and you just need this to find the length of this. So this thing, according to Pythagorean theorem, right? Like if you just rearrange the values, you realize that it's just a squared plus b squared is equal to c squared, right? Like 1 squared plus this value here is equal to square root of 65 squared, which is just equal to 65, right? And so this length is just 65 minus 1 square root, which is equal to root of 64, which is equal to 8, right? So it's just 8. So then you find the area by finding the areas of these two triangles and then adding them. So it's 4 times 7 divided by 2 plus 8 times 1 divided by 2, right? So that's just 14 plus 4, which is equal to 18. Next question then. How many squares can you get by choosing 4 vertices from the dots below? Okay, for this question, I mean, because there's not a lot of dots, you could probably just count the squares, right? Like there's 9 like small 1 by 1 squares. There's, if you count like 1, 2, 3, 4, right? There's 4 2 by 2 squares. And then if you count 3 by 3 squares, I mean, there's only 1. So I'm going to draw it out, right? There's 1. And then notice that I'm not very good at drawing here, but this ideally is a square made of 9 smaller squares as shown by the big picture here. But otherwise, now that that's done, you find the diagonal lines, which can also form a square because each of these are the same length. There's 1, 2, 3, 4. There's 4 of these if you draw it out. So diagonal is 4. And then you notice that you can make a bigger diagonal that goes like that. And then, wait, no, hold on. It goes like that and that and that and that, right? And then you can make another one going this way. So that's 2. Just draw a bigger diagonal. That's 2. Okay, and then you do some addition and you find that it's 10 plus 10, which is 20, right? Okay. Thank you for watching. Bye.